This is an executive due diligence report on Neuralink and its just announced $650 million Series E fundraise. I am going to break down how this round of financing cements Neuralink's leadership position in the brain-computer interface. Space how their successful fundraise came to a pivotal moment in time, what the unique role of SpaceX and Starlink play in all of this, and why I believe this technology will transform our relationship with computers. We are on the cusp of a new technological era in which the human brain can communicate with machines in real time using only thought. I am going to share my own scenario analysis of how this might play out over the coming decades and the challenges we need to overcome to get there. If you find this video helpful, please do me a favor and hit the like button so that YouTube knows to suggest this content to more people. 1. Executive summary. Neuralink has successfully closed a $650 million Series E funding round, bringing the company's valuation to almost $9 billion. The oversubscribed Series E round was led by investment firms ARK Invest and Sequoia Capital, with participation from top-tier technology investors including Thrive Capital founders, 𝗕𝗫𝗣𝗟𝗔𝗜𝗡𝗞, Human Capital 𝗕𝗫𝗣𝗟𝗡𝗏 partners 𝗕𝗏𝗍𝒑𝒠𝒫𝗏 Lightspeed and others. Why does this fundraising deal matter? What makes it more than just another big VC round? Why now? And what does it mean for the future of Neuralink? We'll dig into those questions. But first, let's start with the headline news. The terms of the deal were first reported by The Information and include a $507 million primary raise, meaning cash put in by new and existing investors to fuel growth, plus a $143 million secondary offering, meaning some early shareholders have chosen to cash out some of their equity stake. The primary portion of the funding round values Neuralink at $51 billion, making it one of the largest private tech companies in the world, larger than Stripe, Robinhood, and Snapchat. Existing investors also sold some shares in the secondary piece of the transaction. For a startup founded less than 8 years ago, this level of scale is remarkable and is a testament to the immense progress Neuralink has made under CEO Elon Musk's leadership. In just a few short years, Neuralink has progressed from developing microelectrode arrays to testing a wireless surgical robot and launching the world's first human trial of a brain-computer interface device. Long-term, Neuralink's true strategic value is probably best realized in conjunction with SpaceX's Starlink network, which delivers global low-latency internet access via a constellation of low Earth orbit satellites. Imagine if we had a global neural internet, a way for brains to communicate directly without needing to rely on slow and cumbersome vocal or gestural interfaces. This combination would open the door for an entirely new digital infrastructure driven by thought alone. This new funding is a major milestone for the company, which will allow them to continue accelerating clinical trials of its brain implant, advancing its manufacturing capabilities, and expanding both R&D operations, all critical to becoming the market-leading provider of BC. 2. Strategic opportunity. Neuralink plus Starlink integration. Starlink offers several opportunities for Neuralink. Here are 4 reasons why I think Starlink matters. 1. Global access to neural-enabled devices. One of the biggest limiting factors in rolling out neural interfaces at scale will be the ability to reach patients anywhere in the world. Starlink's ground station network can connect Neuralink's robotic surgeons and neurologists with patients in even the most remote locations. 2. Cloud-based neural computing. Because Starlink provides low-latency broadband connectivity, it enables Neuralink to move much of its data processing offsite. Instead of relying on local compute-constrained devices close to the brain, Neuralink could process neural data from multiple sites around the globe, taking advantage of economies of scale and advanced cloud-based artificial intelligence. 3. Real-time control of distant systems. With the ultra-low latency provided by the Starlink network, Neuralink users could control robotic systems thousands of miles away. A person paralyzed in their home could drive a drone halfway around the world to plant a flag on a distant mountain peak, all using only their thoughts. For a brain-to-cloud data flow, The combination of Neuralink and Starlink creates a direct path between your brain and the digital cloud. You can imagine this as kind of like a giant worldwide API that you can connect your brain to. As these examples show, the combination of Starlink and Neuralink opens up a whole new world of possibilities for the future of humanity. Together, they could make it possible for anyone in the world to control any digital system with only their thoughts, ushering in a new era of thought-driven autonomy. 3. Market landscape and functional niches. I see 3 functional niches emerging in the brain-computer interface market, and each of the key players occupies one of these spaces quite nicely. First, there is Neuralink, which stands apart with its ability to restore high-bandwidth motor, speech, and potentially even vision functions through invasive, precision-placed neural implants. Then there is Synchron, which recently received FDA clearance to begin clinical trials of its own brain-computer interface system. Synchron's less invasive approach involves a minimally invasive stentrode inserted through the jugular vein, which is guided to the motor cortex using real-time ultrasound imaging. While Synchron's technology is more clinically conservative, it still allows patients with paralysis to type using a cursor controlled by eye movements on a screen. Speech recognition is also possible, but in much earlier stages compared to Neuralink. Another competitor, Starfish Neuroscience, is an early-stage startup that's taken a different approach to Neuralink and Synchron. Instead of using invasive implants, Starfish focuses on wireless multi-region systems with no internal battery. This low-power, decentralized design is attractive for academic and open development environments, but its appeal to commercial developers is less clear given its lack of bandwidth. It can only handle around 1 kilobit per second of data, which is insufficient for complex motor control tasks. Compared to Synchron and Starfish, Neuralink's system is more invasive, but offers higher signal fidelity and potentially greater bandwidth, making it suitable for a wider range of applications, including text, movement, and potentially even vision restoration. Moreover, Neuralink's robotic surgical approach offers advantages in terms of scalability, precision, and speed. For intellectual property and platform strategy, it's important to understand how Neuralink protects its technology and where it has a sustainable competitive advantage. As of February 2024, Neuralink holds over 60 patents and has dozens more pending. Their IP portfolio focuses on high-density electrode arrays, neural data interpretation and compression algorithms, and robotic surgical implantation methods. In addition to its patents, Neuralink has also trademarked a suite of product names including telepathy, telekinesis, and blindsight. Starfish Neuroscience IP emphasizes wireless power delivery, low-energy operation, and support for academic research. However, it's still early stage with limited commercial protections. Synchron IP focuses on implant design for vascular deployment and has strong regulatory IP, having benefited from early engagement with the FDA. In summary, Neuralink has built an integrated IP stack that controls the entire BCI experience from hardware and surgical robotics to signal software. This full-stack approach gives Neuralink complete control over its technology, which is something no other BCI company currently has. 5. The mind control revolution. Scenario analysis. Here are my scenarios for how the revolution will likely play out. Keep in mind these are my opinions and not financial advice. Near term, 2025 to 2028, Neuralink will be used to restore communication and motor function for patients with locked-in syndrome or spinal cord injuries. Commercialization of mind-to-text and mind-to-mouse features will begin with an initial developer audience. We'll see the release of early developer tools to help build applications using neural inputs. Midterm, 2028-2032, Neuralink integrates with global cloud infrastructure, aka Starlink. Scalable consumer-grade neural interfaces hit the market. Applications in defense, telemedicine, AR, VR, and industrial robotics become practical with real-time neural control of distant systems. Long-term, Post-2032, brain-based search engines and interfaces will emerge. Think to query, think to type, enhanced human cognition via AI augmented thought prediction. Social and ethical transformation will occur around neuro rights and privacy. Neural communication between individuals, brain-to-brain interface. With Neuralink and Starlink, we are entering an age when the boundaries between our minds and machines will blur. No longer will we need to rely on cumbersome interfaces to communicate with computers. Our thoughts will be the input and autonomy will be the output. 6. Risks and strategic recommendations. There are several risks that could hinder Neuralink's progress. First, despite recent advancements, surgery to implant the device remains highly invasive and risky. Second, public mistrust over brain data access and manipulation could lead to backlash. Third, there are complex regulatory considerations around medical devices and neuro rights that could slow adoption. Fourth, military or surveillance applications of the technology face significant opposition. Finally, maintaining secure, low-latency thought data across a satellite network presents engineering challenges. To mitigate these risks, I recommend the following strategic actions. First, Neuralink should release open neural interface SDKs to build a robust developer ecosystem. Second, develop strong neural data encryption and cybersecurity frameworks. Third, engage proactively with regulatory and bioethics institutions. Fourth, form partnerships with leading AI research labs to safely integrate predictive cognitive models. Fifth, invest in building public trust through transparent communication and patient advocacy engagement. 7. Conclusion: this latest round of funding for Neuralink solidifies its position as the leading force in the BCI space. With unmatched technical sophistication, expanding investor confidence, and access to a global neural internet via Starlink, Neuralink is poised to lay the groundwork for a mind-driven computing revolution. The implications for healthcare, communications, defense, and digital augmentation are profound. By remaining at the intersection of neurotechnology, AI, and satellite infrastructure, Neuralink has the potential to become the foundation of the next interface epic one, where thought is the input and autonomy is the output. Thank you for watching this video and supporting this channel. If you found this video helpful, please do me a favor and hit the like button so that YouTube knows to suggest this content to more people. I appreciate your support and hope to see you in the next video.